Here's a brief demonstration on the ARM Studio STPA application. To start with, I've started a project for us with the chemical reactor design. Here's a bit of the information that you'll enter in for the project. We have a business entity for the HS Orca. We'll be doing some modeling here, and then we'll get the analysis, and then also the unsafe control actions, as well as the loss scenarios. So the very first thing is we're going to set up the losses for the analysis. So I enter in a new loss here, and then I've defined my 3 losses here. I'm going to move to the next part, which is defining my hazards. Here's the plus sign again. Create a new hazard. Notice that each of the losses and hazards have their own unique IDs. This can be adjusted if necessary. By default, this is what's provided. Now that I've created my 3 hazards, you'll notice each one is here in bold. So I'm going to use the Control S save to save these. And then if I look over here, in this lower box down here, you have the losses that we also created, L1, L2, L3. And so the first thing I'm going to do is start to connect the hazards to the losses. So the liquid ratio on the reactor vessel unbalance would be no resulting product or damage to the plant infrastructure. A reaction temperature outside a nominal range. We'll call that resulting product of poor quality. Save that. To give you a quick visual example, we have a relationship diagramming. You can also move from here to create new items if necessary. You can create a new one, a new hazard here, and therefore I can also create a new loss, and then I can link these together real quickly. So that's how that would work if you want to do that. I'm going to close that out, and then we're going to move into the constraints. And I've already created a quick constraint for us. We're going to use an automated computer. It's the main controller for the process. Bit of description here. All those fields can be entered down here, and they also have their own IDs. Now we're moving on to the control structure model. You can see this is named the same as our project that we already have. Any system goals or information that we'd like to enter in will be here. Any description for the scope purpose entered in there. Next step is to start the actual diagramming process. The very first thing to do is grab it in a controller, type in a name for the controller, and the next thing is that we're also going to add in another controller, and this was going to be the main controller, which is the computer we had to add in there. And we're going to connect these real quick by dragging over a connector here for the control action, and then we're going to drag in a feedback as well. And now we have our control loop for the operator to the main controller. We should also start to label this control action, and the first one we're going to have is a start, and then we're going to drag in a second control action for us, and now we're going to build this out a little bit more, and I'm going to use the shortcut here. I'm going to add in my control process. Now I've done that, I'm going to simply type in the name. And now we will save this. Build this out a little bit more. We're going to give the operator actual manual access here. So we're going to create another control action down here, slide that over some, grab a control action for the operator, a little bit more. Now the operator has manual overrides compared to the automation built into the controller. So this is our first diagram, very, very basic. If we want to build this out a little bit more, we can actually go to another one that we built, a different chemical reaction, basically the same. You can see there's some differences here. We've changed the coloring. A lot of that can be done, add in a lot more details. Open up the UCAs, and we already have defined our categories that we'll be using for the UCAs. Not provided, provided causes hazard, incorrect timing order, stop too soon, apply too long. Added in all of our control actions, and they've come in here default directly from the control structure diagram. You can actually rearrange these if you'd like to change by source or by target, whatever you see fit, or by name. So if we just use the source here First one we have is the open water. Just select open water, and then we'll go in and do the first UCA. We say not provided causes a hazard. We think that is the case. See the UCA 1 is identified here for traceability. The computer does not open water valve when the catalyst valve is open and the water is closed. Next thing we'll do is look at another UCA for us. We could say provided causes a hazard. At this point, we can just say assessed, add in a justification. If we want, we'll just write no UCA, incorrect timing or order. And maybe we think that's another UCA for us. Add that in here and put that in. Computer opens the water valve more than X seconds after the catalyst valve opens. Now we'll be able to look to see if this is something that we can actually connect to a hazard if we feel that's necessary. So the liquid ratio on the reactor vessel is unbalanced, and quite possibly the rate of extraction quality is inefficient. And then we can also look to see if there's any constraints, but we haven't put in any other constraints besides a system level about the computer. Same thing for the first UCA, we can connect that. Computer does not open the water valve. Say the liquid ratio is unbalanced. And now we'll save our work. Now we identified the UCA 1. We probably have a constraint that we can build in for it. So we'll use the plus sign here, create a new constraint down here. The computer must open the water valve when the catalyst is open. We can see that this is now going to be connected to the computer does not open as a part of that first UCA. And this is now SCC2. So we just added 3 safety constraints. We connected each of those constraints to those UCAs that we created that are here. We could do the same thing from the UCAs actually. Select this UCA, select the constraints icon. You can see it's already checked. And if there's additional constraints, we could add in that as well. Same thing with the hazards from here or from the constraints as well. We can connect these to the hazards. So that is our UCA. And one other additional thing we can do is we can actually check our progress by selecting the status analysis progress meter. It gives us a basic indication of where we are at. And we can see that these are the control actions that we have identified and they have not been assessed. So we have more work to do. It says 2 out of 10 control actions have been assessed. Please review the following 8 issues. Then moving on to the final part, which is the loss scenarios. We're simply going to open up loss scenarios here. We're going to close out the progress meter for UCAs. And within the loss scenarios, again, we have the same items we've already identified. The open water and the open catalyst, which is part of the UCAs that we have. And you have, again, the source and the target that are identified for you here. So if we look at the open water, which we determined was a UCA here, and the main controller, where it comes from, additional information can be added out here. Here's our actuator, and then the control process of the chemical reaction. And you can see there are no sensors and no feedback, but the feedbacks are over here, so we can actually add in the water status, the catalyst status, and the extraction quality to determine where we want to see. And then the next piece is to determine if we want to do a loss scenario based on the UCA or a loss scenario based on the hazards. And the same will hold true for the second control action. As we open catalyst, we can turn on the feedback so we can have a view. Maybe we're not concerned about the extraction quality, so we can just look at the water. Now we're just going to simply create a new loss scenarios for the unsafe control action we have determined. And here we can also choose the source, whether it is just the controller or the feedback, and of course controller and the feedback. And that is our loss scenarios. And again, same progress meter. We're able to evaluate the progress, and it tells us that we have 2 of 10 because we have more control actions to evaluate in the UCAs and the loss scenarios. So here we generate a full report since we want to see everything that we can go through and see the information available to us, STPA project data that we entered, models that we created. Here, started with the losses and hazards identified, the relationship, the constraints that we were using. Then we have our UCAs. then the list of information, and then the loss scenarios at the end.